Good morning, afternoon, and evening, everyone. Welcome to our today's SolidWorks user group meeting. My name is Johannes Durje. I'm the leader of Addis Ababa SolidWorks user group, the only SolidWorks user group active in Ethiopia currently. And we are delighted to see you all join today from different parts of Ethiopia and beyond. And today we are honored to host Engineer James Letson, a senior designer at ALTEC Industries, based in Birmingham, Alabama, USA. James is not only a highly experienced designer with over decades of experience in SolidWorks and AutoCAD, but he is also a certified SolidWorks expert, CSWE, and also SolidWorks champion. Clearly, his title shows his deep technical mastery and commitment to helping others grow in the SolidWorks community. And in today's session, James will be guiding us through advanced techniques in SolidWorks sheet metal, sharing his expertise and tips that have set him apart in the industry. It is very exciting opportunity to learn directly from the best. Throughout the session, presentation, please feel free to drop your questions in the chat box while James presents, or at the end we'll be having a Q&A sessions will be activated. You can also ask your questions by the end of the presentation. James will be addressing them one by one. Once again, thank you all for being part of the community, and let's make this today's session both engaging and inspiring, and let's get started. James, you can start.
Awesome. Thank you for the glowing introduction. I don't know if I would consider myself an expert, but I appreciate it anyway. Just give me a thumbs up or something telling me that you guys can see that, and we will get started. As Johannes said, my name is James Letson. I am a senior designer at ALTEC Industries. I've been there going on 6 years now. I am a SolidWorks champion. I am a user group leader as well. I run a user group inside, it's a internal to ALTEC user group, so it's a company specific user group for my specific location. As of about January of this year, I am, like Johannes said, a certified SolidWorks expert. I do have my CSWE certification. And then some personal stuff. I am a motorcycle enthusiast. I am a bit of a coffee connoisseur. I actually roast my own coffee at home, which is one of those interesting tidbits that everybody seems to like. And then, as well as that, I am an amateur photographer. That picture of my motorcycle there, I took that one myself. So the QR code that you see on the screen in front of you will take you to my like virtual business card. It should have like a LinkedIn and maybe an email address on there. If you want to connect on LinkedIn, please feel free to do that. I accept most connections. I won't say all, but most connections I accept. So that's a little bit about myself. And from there, let's just go ahead and get straight into the presentation. So the things we're going to talk about today, we're going to start talking about the sheet metal trinity. We'll talk about mastering the 3 core sheet metal techniques. And then we'll move on to flattening the curve, unlocking the secrets to flat patterns. And then third, we're talking about geometry gone rogue, taming imported parts for seamless design. And then finally, we will think outside the fold and talk about creative solutions using sheet metal features. So we'll hop right into the beginning of the sheet metal trinity. And the first thing I want to talk about is the insert bend command. So insert bend is kind of the OG sheet metal feature, the original feature that SolidWorks added in their software for sheet metal, added in 1997, which, if you know, as of this year, we are celebrating 30 years of Solidworks. So that tells you that this has been there since Solidworks was only 2 years old. So it's been here for a while. The cool thing about insert bend is that it can be used for cylindrical and conical shapes. It can be really powerful when dealing with imported geometry, which we will see later on in the presentation. And then some drawbacks to insert bend is it does need uniform wall thickness, and it doesn't like if corners already have radiuses. So what we're going to do now is we're going to hop into SolidWorks, and I'm going to show you insert bend in person. So if we come up to the sheet metal tab, if you don't have the sheet metal tab up here, if you right click in anywhere on this taskbar up here, come down to tabs, you can toggle sheet metal on. But we'll come to the sheet metal tab, and all the way at the end, just by default, all the way at the end, insert bend is down here at the end. So the example I'm going to show here is the typical use case for insert bend. And basically what I've done is I started with a solid model. I got the overall shape that I wanted it to look like. And then I shelled it out, deleting the top and the front face to make it look kind of like what a sheet metal part would look like, right? So from there, I'm going to go ahead and hit this insert bend button. And it's going to ask me for a few things. First, it's going to ask me up here on the top, it's going to ask me for a fixed face. So to me, it makes sense that this bottom face down here is going to be our fixed face. That's what everything's going to unfold around, right? It's going to ask me for a bend radius. I'm just going to keep it at what it is right now. And then what I'm going to do next is I'm going to choose the edges that I want to be ripped. So when you think about a sheet metal part, you think about, okay, it's a flat piece that has multiple bends, right? And we can look at this part and we can say, okay, you know, this corner here, this corner here, this corner here, all makes sense to be bends. You know, same on this side. And then maybe this back one here makes sense to be bends. But we also have corners that don't make sense, right? We have these internal corners that if this was actually a sheet metal part currently, those wouldn't be bends. So that's what this is asking for. It's asking us to choose the corners that it wants, you want SolidWorks to rip. So we're just going to start choosing the corners that we don't want to be bends, basically, right? And choose all 6 of those. And then when I hit the green check mark, I'm going to get a quick dialog. It's just like, hey, auto reliefs were added. You hit OK, and now you can see that I have a actual sheet metal part. You know, I have a sheet metal feature over here in the model tree now. And if I come up here, I can hit this flatten button, and the whole point of it is it can be flattened, right? So that is the gist of how insert bend works, right? There's a few more things I want to show about this. Let's see if we will. I'm just going to Control Z and undo what I just did and come right back into insert bend one more time, and then just speed through the steps I just took and get right before I actually make the part. Okay, so from here, what I want to show you is you see all these little yellow arrows that are popping up as I click these edges. So like, you know, if I unclick that one, it goes away, and if I click it, it comes back. So these little arrows allow us to determine how it cuts these corners. So for instance, let's say we want this back like T-shaped piece to be overlapping the other flanges, right? So basically we want these flanges in here to be cut back to make room for that back flange. So what we're going to do is we're going to hit the arrow towards the direction that we want it to cut. And if we do it, maybe we want it like that on this side, but just for show you how it works, let's do it the other way on this side, right? So now when I hit the green check mark, you can see that on the side that I ripped in, this is overlapping. So my back T is overlapping on this side. But then on this side over here, you can see it is inset, and it cut the back flange away instead of cutting the side flanges away. Okay, so let's hop back into the presentation real quick, and we will just breeze through this next slide because this is just explaining what I just went through. You start with a thin feature solid body that has uniform thickness. You choose a fixed face and edges to rip, and then you end with a sheet metal part that, again, can be flattened, which is the whole point, right? So the next thing I want to talk about is the base flange and friends feature, or, you know, that is the next sheet metal trinity, the feature in the sheet metal trinity. Base flange and tab is kind of the de facto standard sheet metal feature. Anybody that's listening, if you guys have ever used SolidWorks sheet metal before, I can guarantee you've used base flange tab. But base flange tab has some friends, right? Things like edge flanges, miter flanges, and jogs. And we'll go into a few things in these that most likely you've used edge flange. You've probably used mitered flange. And you've probably even attempted to use jog. But jog is one of those that's a little harder to understand. And I will explain it, and then I'll show you something in each one of these features that I like, that I think is a bit overlooked and is a little bit more intermediate or advanced features within these features. So I'm gonna hop back into SolidWorks one more time and change over to a different part. Okay, so I'm gonna roll this back real quick just to kind of just to be able to show you some of the things that I want to show you. So base flange and tab starts kind of similar to the way that insert bend does, except we don't have to make a solid model first, right? We can start with sheet metal. So what I've done here is I've made a thin feature sketch. So you can see by the construction line here that it is not a solid sketch, right? It's not a closed contour. So I made a thin feature sketch, and then I came up to the sheet metal tab and I clicked base flange tab, which is the first feature on the sheet metal toolbar. And when you click that, you get some selections that look like this, kind of like this. That let's just go back one more. No, it ain't gonna let me. Okay. Yeah, so you get some, I clicked the wrong button. Here we go. You get some features kind of like this. It's going to ask you for a direction, and in this case, I chose mid-plane, so I want it to go in both directions from my sketch. I could go blind like that if I wanted to do that, but I'm going to keep it at mid-plane. I choose a length, so from end to end is 6 inches, and then in this case, I have a gauge table set, so it has given me default sheet metal parameters that I could override if I wanted, but ideally I use a gauge table. Hit the green check mark and I have a sheet metal part. So now I want to talk about the first friend for base flange, right, which is edge flange. This is one that everybody has probably used if you've done any sheet metal features. And I will just kind of show you a few things about this that I think are interesting. So edge flange is up here at the top. It's about 4 in at the top of this column here. We click edge flange, and what it's going to do is going to ask us to choose some faces or some edges, sorry. So let's say we want a flange coming out this edge here like that. And then I can, set a distance. So let's say I want it to be a 2-inch flange. And then the first thing I want to show you in the edge flange feature is the flange position, which is right here. You can see my cursor, right, Johannes? I've been pointing to stuff with my cursor, and I hope you can actually see it. I always forget to check. Someone in the chat or someone just tell me yes if you can see that. But flange position is right below where you choose the length. Thank you. And what this is, and I'm gonna go normal 2 here. I clicked the wrong button. Crap. Go back one more time. Edge flange here, and set it to 2 inches. So I'm going to go normal 2 here. Maybe. There we go. Normal 2 here to kind of show you, so I can zoom in and show you what this is actually doing. So what I have chosen right now for flange position is the option that is bend outside. So you can see this gray part is my original sheet metal part. And right there where I have highlighted is where it ended. So what flange outside, or what bend outside does, is it adds material for the bend and for the flange. So you can see the entire bend is outside the original material. So if I click this next one over, this says material outside. So what this is doing, you can see it just shrunk, right? What this does is it gives the bend radius, which I have set at 0.134 up here, just from gauge tables. It's just defaultly set. That inside bend radius is completely inside the original length of the flange. And then the next one is material inside, and you can see that it moved again. And that just means that the overall outside to outside of your new flange is going to be the exact length that the existing flange was, right? So that flange was 2 inches, and I can double click over here, and you can see I have a dimension set for 2 inches. And with it set like that, I can click outside to outside, and I can measure, and you can see it is exactly 2 inches, right? So that's the flange position inside the edge flange. But let's hop back into edge flange. Let's show you one more thing. Okay. So cool thing about edge flange is you don't have to just do one flange at a time, right? I can come over here and I can click that flange and it can give it to me as well. I can even make some modded flanges, and it will, if I hit this green check mark, you can see it has already added a relief, and it is calculated what the corner needs to look like to make this manufacturable, right? But let's go back in here one more time, and let's say maybe this flange over here, maybe we don't want it to be full length, right? Maybe we only want it to be, 2 inches wide right in the center. So I could exit sketch and or exit this, undo this flange on this side, and I could add some kind of tab over here that was the exact length, or exact width that I wanted it to be able to add an edge flange to. But there's an easier way to do it, right? I can change the sketch profile of all my edge flanges in this single edge flange feature. So I'm gonna come up here and I'm gonna choose this edge flange, and then when I click it, you can see it highlighted the edge that I have chosen. If I go 1, it highlights over here. If I go 3, it highlights this vertical one here. And of course, this is the numbers are the order of operations that you chose these, right? So I'm going to choose edge 2, which is the one that I want to shorten. And I'm going to hit this edit flange profile. So when I do that, you can see it takes me into a sketch. I got this little profile sketch completion box up here. But it go ahead and takes me into this sketch here. And if I hit Control 8, I can go normal 2. And you can see this is the profile that is defaultly set by the edge flange feature. But the cool thing about this is I can just click, even though these lines are black over here, they have what I like to call soft relations. So they are fully defined at the moment, but a simple click and drag breaks those soft relations and allows me to edit them however I need, right? So now let's say I want this to be centered on the, let's center it on the center line of the flange that it was. We'll make that vertical here, and then we want it to be 2 inches wide, like that. And it did not center where I wanted it to, did it? Okay. select midpoint and select that and make coincident. There we go. Now we're centered. And now when I hit finish, you can see I have a flange that I edited the sketch profile in the edge flange feature. Okay, so now let's go back one more time into this edge flange feature, and I'm going to change my flange position like I showed you before, and I'm going to exit, and I'm going to measure this new flange here and get this measurement, and we see that we're a little over 2¼ inches, right? 2.2595. But what if I want maybe that distance is right for this side. That's what I want this side to be over here. But on this left side here, maybe I want that one to be, I want from top to bottom to be, let's say, 5 inches. I could come in here before I add this edge flange, and I could add a tab that's exactly as wide as I need it, where I want it. That is an additional 3 inches long, and then add the edge flange to the bottom of it. But there's an easier way for that as well. Let's come back into this edge flange one last time, and I'm going to choose edge 2 again, because that's the flange that we're in question that I want to extend. And then what I'm going to do is I'm going to come down here below flange position to this little offset checkbox. When I click this, you can see it's actually offsetting everything, which I did not realize it was going to do, but that will be fine to show you now. So anyway, what I'm going to do is, instead of that 2¼ or whatever it was, maybe, like I said, I want it to be 5 inches tall. So what I'm going to do is I'm going to say offset. I'm going to say offset from surface. I'm going to make it 5 inches, and then I am going to choose that surface, and it reset my dimension, but we'll change it right back to 5 inches. And then when I hit the green check mark, you can see that it has added material for what I want, and I now have 5 inches plus a material thickness. So what I can do instead is I can come back in one more time, and I can change my flange position like that, and of course 5 inches, and that should give me my exact 5 inches. Yes, it does. That's my 5 inches. Cool. Okay. Question in the chat: can you show how to do automatic intersection joint like tab and slot, but the plates are intersecting? Unfortunately, I do not have anything in my presentation for tab and slot. It's not something that I use on a day-to-day basis, and I honestly feel like it is still in the beginning phases of its life. Like it's a fairly new feature, and I feel like it needs some additional updates to really make it useful in a lot of applications. So unfortunately, I do not have anything in this presentation for tab and slot. I apologize. So I'm going to come back, and I'm just going to undo that offset so we can move on. Okay, so the next thing I want to talk about is mitered flange. Still in the base flange and friends section of this sheet metal trinity, right? But mitered flange is right below edge flange. And the thing I want to show you about mitered flange is you don't have to. So the way mitered flange works, when you click it, it's asking you to sketch, right? It's going to ask you to make a sketch that is the profile that you want the mitered flange to be. So you don't have to make the plane ahead of time. What you can do is, as soon as you hit this mitered flange, if I come in here and I click the edge that I want the mitered flange to start from, you can see that it's already given me a origin. And what that's done, if I hit this exit sketch button, you can see that it has given me it has created a plane for me to start from. So we will do that one more time and go ahead and show you how mitered flange works. I'll actually click down here towards the bottom so it puts my plane towards the bottom. That's another little trick there. If I want it to come from this edge here, if I click towards the top, it's going to go to the nearest intersection, right? So if I click towards the bottom, it's going to put my plane down towards that bottom corner. So now I'm going to hit Control 8, which is going to give me a normal 2 down here. And then I'm going to just go ahead and sketch something. There it is. Okay, Control 8 one more time. Okay, anyway. So let's say we want this to come off something like that. And what modded flange does is it is going to make a flange off of this edge, following this profile. When I exit sketch, you can see that it's going to populate like this. But the cool thing about modded flange, kind of like edge flange, is I can choose adjacent edges, and it's going to follow that flange is going to follow around that adjacency. So I can click up here and you can see it go ahead and gives me a preview, and I can click down here. And the cool thing about modded flange is that it makes these bin reliefs, the cut reliefs automatically. If we come back into here, I can change the gap distance. So like this distance here between these two flanges, I can, maybe I want it to be 1/8 of an inch, right? And there's my 1/8 of an inch gap. And then I can also offset. So kind of like the editing the sketch, or the flange sketch like I did over here, I can kind of do the same thing where, if I want to offset it from the edge there, you can see I'm offsetting it from the edge. And then there's the other one on the other side. I can do it as well. So that is edge flange. And then the last thing I want to talk about in the base flange and friends is going to be the jog feature. And there's one particular feature inside this command that I like to show. So we're going to use this edge flange over here that we created earlier to show you this jog feature. I'm just going to go in and I'm going to make it a little longer. So let's make it 5 inches. We'll make all of them 5 inches long just to give me a little extra room to show you the jog command. Okay, so the way jog works is kind of similar to the way modded flange works. When you click it, it's going to ask you to choose a face on which you want to sketch. And what you're doing here is you're sketching bin lines, right? So if I want to jog this face here, let's say it comes out, maybe I want to jog it up and then out again. So I'm going to click that face and it's automatically taking me into a sketch. And I'm going to go Control 8 again to go normal 2. I'm going to grab me a line. And then from here, it doesn't matter like whether this line intersects or ends on a flange. I can literally just drag it like this, and it doesn't have to end anywhere certain. But what this is this is where we want our jog to take place. Right, so I could put it, I could put it closer, but let's put it somewhere close to the middle here. And when I hit exit sketch, it is going to go ahead and bring us into the jog command. And just like the other sheet metal features, it's going to start by asking you to choose a fixed face. So I want this face to stay the same, and I want the left half, to the left of this line to be the one that is jogged up and over. So I'm going to choose the right side of the line to be my fixed face. And you can see that it is going ahead and giving me a preview here. So the cool thing that I want to show you, or the interesting feature inside this command that I think is overlooked that I want to show you, is this little fixed projected length button here. If you've never used jog before, this button, or even if you have, you may have overlooked this button. Maybe you don't know what it does. But I want to explain because I think it's really cool. So before I do that, I'm going to exit sketch real quick and just show you that the length of my flange that I set on that edge flange is exactly 5 inches, right? That is the length of the flange. So when it comes to doing jogs, design intent really comes into play here. When I designed this original edge flange, knowing that I wanted a jog, did I design it with the intention of the jog being 5 inches long, or this flange being 5 inches long, even with the jog? Or did I design it with the intent of, no, this is what I want the length to be as a flat, and then I want it to use the material that I have to make that jog? Let me hop right back into this jog real quick and kind of show you what I mean there. Sheet metal jog, and choose my fixed face one more time. Okay, so with this fixed projection length set, if I just hit the green check mark and create this jog, you can see that my total distance of this is exactly 5 inches still. So that's what that fixed projected length is doing, right? It is taking the length of this original flange, the end point, and it is literally projecting it up and then adding material to make it that length, right? But like I said earlier, what if this 5-inch flange was the length I wanted it to be in the flat pattern? I don't want it to add this extra material, right? And I'm gonna come normal to here and zoom in just to show you. When I uncheck this fixed projected length, you can see that that yellow projection is gonna get shorter, right? So now when I hit the green check mark, you can see that my overall length of this flange is no longer 5 inches. But if I were to flatten this, you would see that it is indeed still 5 inches. So that's what that fixed projected length is doing. It's whether you want it to add material, right? So if I click it again, you can see it's adding material. Whether you want it to add material to keep your existing flange length. Cool. So that is base flange and friends, and let's hop right back into the presentation. So again, we're going to skip over this. This just explains again how the base flange friends works. You start from a thin feature sketch. You choose thickness, bend radius, K factor. You get a preview, and then you end with a sheet metal part that can be flattened. So the next and final of the sheet metal trinity that I want to cover is the convert to sheet metal feature. So convert to sheet metal is the one of the newest sheet metal features as far as like the most powerful sheet metal features, right? The cool thing about sheet metal features is it allows you to convert solid bodies into sheet metal parts, but without the making it look like a sheet metal part before, like I did on the insert bend at the beginning. And then once you do that, sheet metal features like the base flange and friends that we just covered can be added. The cool thing about it is it's super powerful for parts with complex angles, and it can be used for multi-body sheet metal parts as well. And then one downside of it is it does not another good thing about it is it doesn't need uniform wall thickness like insert bend does. So if you have something that you have modeled, or someone else has modeled, say it's an imported part, which I will show you an example of later on, but it's an imported part that they've made it look like a sheet metal part, but they didn't do a good job of making sure that the thickness is uniform, convert to sheet metal is what you're going to want to use. So the way convert to sheet metal works is you're going to start from a solid body. You're going to choose a fixed face, just like you do on most other sheet metal commands. You're going to choose your bend edges, and then again, you're going to end with a sheet metal part that is flattenable, right? So I'm going to hop back into Solidworks again, and I am going to come over to this. This is the solid part that I've made to show you how convert to sheet metal works, right? So what I've done here is I have started with a rectangle. I added some cuts, and then I added some draft. And I still have some sheet metal features in here apparently, so let's go ahead and delete them. Okay, so this is what you will start from when using convert to sheet metal. But if you think about, this is some kind of hopper, right? if you think about trying to create this with your base flange and friends, your typical sheet metal parts, things like this draft on the sides, you can see it's drafted this way on both sides, and the back is drafted as well. Things like that is going to be very hard to create the sheet metal part with the base flange command and its friends. So what I'm going to do is I'm going to show you how to use convert to sheet metal real quick and make it easier on ourselves. I'm going to answer a question in the chat real quick. If I make a solid body and then make it sheet metal, is it recommended, or should we make it with the features of sheet metal only? So it's a bit of a the easy answer is it depends, right? Ideally, you start from sheet metal. On something like I have shown before, like this part here, I would absolutely start in sheet metal on this part. But the whole reason of me showing convert to sheet metal is because, like I said, sometimes doing the base flange friends starting from sheet metal because of the shape that we want the part to be ultimately is not easy. In that case, I would start from a solid body and then convert to sheet metal. Or the other instance would be if you have a imported part, you're doing outsourced work from some, or you have somebody outsourcing some work or something, and they make parts for you and they send them back and they end up sending them in like an IGS file. And now your job is to convert those IGS files to sheet metal parts. Then of course you instead of just starting over and making the parts, there's an easy way to convert it. And I would definitely recommend that. And that kind of answers the next question as well. What are the scenarios where converting to sheet metal tool is not applicable? If you were making a part yourself and it's a fairly simple, like, and when I say simple, I mean mainly like 90-degree bends, I wouldn't worry about doing a solid first. But something like this, where you have multiple angles at multiple different, multiple sides at multiple different angles, that would be where I would use the convert to sheet metal. But let's go ahead and get into how it works. Convert to sheet metal is right beside base flange tab up here on the sheet metal toolbar. And when I click it, like I said, it's going to start by asking you for a fixed face. So to me, it makes the most sense for this bottom horizontal face to be fixed. So I'm going to go ahead and click it. And then it's going to, from here, I can choose a bend radius and a bend radius and a material thickness, or I can also use gauge table if you have gauge tables already set up. But what it's going to do from here is it's going to ask you for the edges that you want to be bent. So this is going to be opposite of what we did in insert bend, right? In insert bend, we chose the edges we wanted it to rip. And in this case, we're going to choose the edges that we want to be the bends. So, but the thing about this is you need to watch the order of operations that you choose your bends. You need to choose them in an order that makes sense, because so let's start at the bottom here. It makes sense that we want these two bends here to be off of that base flange, right? But this face here, we probably don't want it off of that flange, right? So let's make sure we don't choose that next. Let's choose this one down here, because to me, it makes the most sense to have it off the bottom flange as well, right? So then, okay, do we want this front face over here to be off the sides? To me, it doesn't make sense. Let's make it off that bottom as well. And then we'll just choose our back face. And when I hit the green check mark over here, you can see I now have a sheet metal part that it has gone in and it has added all my bend reliefs that it finds necessary, and you can adjust those things, right? But again, it is flattenable, which is again the whole point of sheet metal, right? Being able to cut something flat and then bend it later. So once this is like this, we can now, like I said earlier, we can now add sheet metal features to, normal sheet metal features to it. Right. So maybe I want what did I do? I chose the wrong thing. Maybe I want an edge flange around the top of this, right? I can choose me an edge flange there. And I will give a quick tip here. Because these are at different angles. So like this face here is completely vertical, whereas the side faces are not. If I were to try to choose those together, you can see that this one is perfectly horizontal, but it's going to put this one at 90 degrees of that face. So what I would do instead is I would uncheck that. I would make that flange, and then I would come up again and do maybe this one and this one together, because then I can change my bend angle, right? And then maybe I want a flange on the back here as well, bring it up to about what looks probably 75. Okay. So that is how convert to sheet metal works. The cool thing about convert to sheet metal, like I said before, is it can be used for multi-body parts. And I will show you what I mean there. I'm going to go ahead and delete these edge flanges. So let's say in this sheet metal part, if I flatten this and we look at this, it's like, okay, unless I have a very specific set of tooling made exactly for this part, bending this is probably not going to be easy. It's not something you're going to do on a press brake, right? Sorry, I had a looking at a question in the chat. How you set shortcut features in your display left side? Oh, you're talking about these commands on the left over here. So that's just a toolbar. If I right click anywhere and I click toolbars, that is my tools toolbar. So, I can toggle it off, toggle it back on, and then I think it defaults somewhere up here, and I just drug it over here to the side like that. There we go. Okay. But yeah, so this part is, it would not be easily manufacturable unless I have a tooling specifically for it, right? So what if we wanted to make this part out of multiple different pieces? So I can, I'm going to Control Z and undo a few things here, get back to my solid part, and then I'm going to come back in to convert to sheet metal one more time. So this little keep body checkbox here is what we're going to utilize here. And I'm going to show you what it does, but I'm going to go ahead and check it now, and I'll show you once I complete the part what it does. But let's start again. Let's choose our fixed face. And let's think about, okay, what makes sense for this part as far as which face it, like if we wanted to make this out of multiple parts and then weld it together afterwards, right? So let's say maybe that bottom face and then maybe, maybe these two side faces, right? That makes sense to me to be one part. That would be easily manufacturable. You cut that out and you could bend that with two hits on a press brake, right? So if I hit my green check mark, you can see that little keep body check mark that I clicked, that's what it did, is it kept the original body, but you can see that my sheet metal part is still here as well. If I come up here to cut list, that highlighted is my sheet metal part, and then it still has the solid body there, right? So the purpose of that is now allows me to create another sheet metal part from that original body, right? So I can come up here to convert to sheet metal again, and I can choose that as my fixed face and maybe this as my next bend. And when I hit the green check mark, you can see I now have two sheet metal parts. I have the original one and I have the second one. And let's go ahead and just make this well, is it not giving me the transparent option? Okay, well, maybe I won't. Well, I was going to make it transparent, but that didn't work. So let's do it this way instead. Let's make body, and then let's, well, there we go. Color, edit appearance. Let's just make it like red. Okay. So now you can see the red is my original body and the gray, and I can come into this, yeah. And the gray is the new sheet metal parts. It looks like we have one left to do, right? So if I come to convert to sheet metal again, I hit this back face, I hit the green check mark because there is no bins. Now I can hide this original body, and you can see now I have 3 sheet metal parts. I have the original one, I have that one on the front, and then I have the back. Of course, you know, it needs some cleanup, right? It makes it to where everything is intersecting. So from here, you would go in and you could clean up those parts. But this would be how you would do a multi-body part with convert to sheet metal. So let's hop into the presentation and let's move on to our next topic, which is flattening the curve, unlocking the secrets to flat patterns. It's going to be talking about flat patterns. So the first thing I want to talk about, the first topic I want to talk about is what I like to call the sheet metal sandwich. But before I get into exactly what I mean by that, I do want to talk about you. At this point, you've seen me hit the flatten button a couple times to give you a preview of what this part looks like flat. I want to talk about what that is and what it isn't, right? So that flatten button, it simply unsuppresses the flat pattern, and then when you click it again, it suppresses it, right? It is not how you create a flat pattern configuration. And then the big thing to know is you do not want to work in that flattened state. Never work in the flat pattern, right? You don't want to hit that flatten button and then add some cuts, and I'll show you why, but it ultimately it will end up just suppressing your new cuts once you unflatten that part, right? So now the sheet metal sandwich that I mentioned just a second ago is a term that was coined by Toby Snars. So he runs a YouTube channel. If you've ever heard of Too Tall Toby, he's probably one of the bigger SolidWorks YouTubers. If you haven't heard of him, I would definitely recommend going ahead and checking him out. He's got a bunch of just an abundance of information and knowledge on his YouTube channel. But anyway, so sheet metal sandwich is a term that he coined that just means in your model tree, you have 2 features, and I have them highlighted there, sheet metal and flat pattern. Those should always be your, and I'm going to use quotations here, right? Your bread in your sandwich. Those should always be on the outside. Your base flanges, your edge flanges, your mitered flanges, your jogs, all of those should fall between the sheet metal feature and the flat pattern feature. Let me finish what I'm talking about, and I will briefly touch on K-factor. So let's see. Went ahead. Okay. So I'm going to hop into SolidWorks real quick and just show you what I mean real quick about sheet metal sandwich. Let's go back to this part over here that we were using before. And let's, okay. So actually, let's delete a few of these things here. And then roll, there we go. Okay. So this part here, if I wanted to add a circular cutout kind of centered over that bend there. And before I get into that, let me explain. This is what I mean by sheet metal sandwich. So those are your 2 pieces of bread, right? And you can see everything that I've done, all of these features fall in between those 2 sheet metal features. This is the way it should always be, right? You never want a cut or a flange or something to fall outside, below this flat pattern. And I'll kind of give an example here. So like I said, maybe I want a cut to be centered over this edge here. And I'm going to show you the way not to do it, right? I'm going to hit that flatten button, and then I'm going to sketch. I'm going to draw a circle here, and I'm going to just go ahead and extrude cut it. So that's kind of what I'm looking for in a flat pattern, right? But if you notice, the cut feature falls below my flat pattern feature, right? Which, like I said, is a big no-no. And the reason that we don't do that is because when I uncheck this flat button, you can see it has suppressed it. That feature is gone, right? So the way that we actually want to do this is we want to utilize the unfold and fold features in the sheet metal toolbar. So we want the bend or the cut to be over that bend there. So I'm going to hit unfold. I'm going to choose a fixed face. I'm going to choose the top face for the fixed face. And then it asks me which bends I want to unfold. So since I want it to be over that bend, I'm just going to click that one, and I'm going to hit the green check mark, and you're going to see it just unfolds that bend. But again, you can see this unfold feature falls before my flat pattern feature. So now if I do the same thing, I sketch, I add a circle, and then I cut extrude, I can now, again, you can see that the cut feature, this circle that I just cut, is before the flat pattern feature. So I can come up here and I can say fold, is automatically choose my fixed face because I had an unfold feature. I'm just going to say collect all bends. It's going to collect the one bend that we want. I hit the green check mark, and you can see there is my formed part with the cut in it like I want, right? So I'm going to go ahead and delete this other cut that I did just to show you how not to do it. But now when I flatten, you can see the cut's still there. And then I unflatten, and it's there in the formed as well. So that's the ideal way to do a cut in a sheet metal part that goes across bends, right? Never work in that flat pattern or that flattened state. You never want to unsuppress the flat pattern and then add cuts or add features. Okay, let me talk real quick on K-factor. I don't typically touch K-factor in this presentation, or I don't have it in the presentation because it is a little bit of a it's one of those topics that you really have to, it's not the same from place to place, right? So K-factor is a, let me just go normal 2 here. And so let's look at this edge of this part, the edge of this part that I have highlighted, right? So what K-factor is it is a percentage of the thickness of the material at which the center of the bend happens. So if I zoom in on this bend, you can see, and maybe you know this and maybe you don't, but the way that sheet metal bending works is the inside radius here, the material, like in real life, if I were to go bend this part, the material on the inside is going to compress, whereas the material on the outside out here is going to stretch and extract and stretch and get bigger, right? I don't know what the word I was looking for. I couldn't find it, but it stretches. So what, and let me actually just do a sketch on this face here, and I will kind of show you what I mean. So if I click, it's not going to let me click that edge, is it? Okay. Exit sketch and sketch there instead. There we go. Okay, so I'm going to convert this to a sketch real quick. And then I am going to offset it, let's say, let's trying to think of the best way to show this. Let's go. So my material thickness is 1/8 of an inch. So let's offset that 0.125 times 0.4. Okay, and then we will offset it the opposite direction. Okay, so what I've done here is, and I probably should have done it off of this inside edge, actually. Let's do that because that is what it will actually do. My bad. Offset entities, was that 0.05? That's what it was. Okay. Okay, so what I've done here is I have simulated what the kind of default K factor is for the center of a bend. And I'll show you what I mean. If I come in here to like base flange and I edit this base flange, let's see, maybe the edge flange. Okay. Yep. Well, shoot. It's not, because I didn't create the part originally, it's not giving me the K factor. I can probably, anyway. So when you create a flange or a part originally, because I already have this created, I'm just editing it, it's not giving it to me. There should be a K factor in there. But so what it is it's a percentage. So I set this at 0.4 of a K factor. And what that means is it's 40% of the way through the material is what the center line of this is. Okay, you're clarifying your question now. Compression and tension exists, but does the material matter when bending? Yes, it absolutely does. So yeah, that's kind of what I'm getting at. And that's kind of the reason I don't put K factor into my presentation is, but I wanted to at least explain what K factor was. So it is a percentage of where the center of the material is. And the reason I don't include it is because not only does it change material thickness to material thickness, right? The K factor for a 1/8 inch material steel is going to be different than the K factor for a 3/16, or could be different than the K factor for a 3/16 material steel, right? But also the K factor for 1/8 inch steel from supplier A could be different than the K factor from 1/8 inch steel from supplier B, right? So not only does it change, or could it change based on what material you're using, but it could also change based on who you get that material from. So when it comes to K factor and stuff like that, bend allowance, bend reduction, the best bet is to work with a manufacturing team and figure out what makes the most sense. So default K factor, like in SolidWorks, if you were to just launch SolidWorks new and make a sheet metal part, it's going to put your K factor at around 0.4, which is a good starting point. But if you really want to get accurate sheet metal parts, the best thing to do is to go through and make some test parts with, so you would change your K factor to different things and have a manufacturing plant or, a fabrication plant bend those parts and see how it comes out and what is closest to the intended outcome. And that's kind of how you determine K factor and what the best K factor is. Getting a little sidetracked, so I'm going to get back into it. That's a good question, though. I appreciate you asking it because, like I said, every time I give this presentation, someone always asks it, and I'm never prepared for it, even though I should expect it. But thank you for the question either way. So the next thing I want to talk about is the flat pattern configuration. So we're still in the flat pattern section of this presentation. The big thing that I want you to take away when it comes to flat patterns is, and you can see it in red there, right? Do not make the flat pattern on your own. Let SolidWorks make this flat pattern configuration for you. And there's a really easy way to do it, and that is just making a drawing, right? Even if you don't need a print, you don't need that drawing. If I have a sheet metal part and I come up to new and I say make drawing from part, and then it makes that drawing, I immediately close it. I don't save it. I don't need it, so I don't save it. It automatically makes that flat pattern configuration. And that is the ideal way to make the flat pattern configuration, because it does it in a certain way that helps us in the long run. So doing it this way, it not only makes it a derived configuration. So you can see on this bottom picture here, the sheet metal or the flat pattern configuration down here is under the default configuration. So it is derived, right? But it also, it gives it a unique naming convention. So this default SM dash flat, and you can't see the rest of it, but it says dash pattern after it. That is the naming. So you could memorize that naming convention, right? And you could name it and get access to what I'm about to show you, but it's easier to just let SolidWorks do it for you. And what that does is it gives us some extra functionality in the drawing. So if you are making drawings, it gives us some extra functionality in there that you wouldn't have if you were to do it a different way. And I will just kind of hop back in real quick and show you. So I don't currently have a flat pattern configuration. And like I said, if we just come up here to new make drawing from part, I'm just going to choose whatever size I need, or whatever size I would need for as far as template goes. And then, so now, like I said, I can close this. I don't need it right now. I can close it, and you can see I now have a derived configuration that is named like it needs to be. So I can double click that and make it active, and you can see there's my flat pattern, right? So that is a big thing to make sure you do properly, because and let's go one more time, make drawing. I shouldn't have closed the drawing because now I actually need it to show you an example. But if I bring this flat pattern over now, having the derived configuration and named the way that it's supposed to be named, it gives us this functionality down here, like our bin lines and bin notes functionality, you know, being able to undo the bin lines or undo bin notes. That's the functionality that we lose by not creating our flat pattern the right way, right? So if I were to create this manually and not do it right, I would not have this functionality, and that can be pretty important. So make sure you're letting SolidWorks create your flat pattern for you. I did not. There we go. So continuing on in flat patterns, we'll talk about editing flat patterns. There's a few things I want to show here. A few different, 3 different items I want to show as far as editing flat patterns. The first one is the fixed face. It's for when your flat pattern is unfolding in a weird way. Merge faces, which is something that makes exporting to DXF or exporting to DWG a little easier. And then lastly, corner treatment for when your corners look different in the formed than they do in the flat view. So I'm gonna hop back into SolidWorks one more time. And I am going to give you an example of this. Okay, so first one was fixed face. So in this base flange here, if I edit it, if I edit the, oh shoot, okay. I got brain folded for a second. Okay, so if I edit, How do you enable those relation arrows that are visible when you hover over a feature? I'm not. Oh, these arrows. If I right click up here, right click my top, these two buttons here is the parent-child visualization. So that's what that is. If I click edge flange, you can see it is a parent to jog flange, and it is a child to these up here. So that's what that is. Right click on. Actually, you can probably right click anywhere. Yeah, right click anywhere on the model tree, and turn the dynamic reference visualization on. Okay, so if I were to come down here and edit this flat pattern feature, I can see that highlighted is what my fixed face is, right? So I'm going to change it just for purposes to show you what I mean. So sometimes when you create a sheet metal part, and it happens a lot if you have something that isn't like 90-degree bends like this, but if you ever create a sheet metal part and then when you go to flatten it, it unfolds in a way that doesn't make sense. So you can see that was the face that I chose, fixed face, right? And to me, that the way that it unfolded just doesn't make a whole lot of sense. It makes more sense for this face to be what it unfolds around. So that is how you change it. You right click your flat pattern feature, edit, and then you just deselect the face that it was chosen and then choose the fixed face. So something that this can something that I've ran into this in the real world is if I have a part and I am making it in a print, I'm making a print for a part, and let's go back one more time real quick and let's change that back to this face over here and see if I can replicate it. So now with this part here, if I were to project this part, so I'm just going to choose projection, and I project it out both directions here. And now watch when I change this to formed, it projects in a weird way. It doesn't project from the center here because I have a different face chosen as the fixed face, right? So if I come back one more time, edit and change it back to the face that I want, and I come back into this print, and then Control Q just to rebuild, and it's because I did it once. Let's just project it one more time, project, and then you can see now if I turn it to default, it's it's projecting in a way that I would expect, centered by origin instead of being offset. So that's what that fixed face. If you don't have it, or sometimes SolidWorks just chooses the wrong fixed face, right? And that's how you change it. So next thing I want to talk about is merge faces. So when I click this flat pattern up here, you can see that it has taken all of my bends and the tangent lines, and it is making different faces for every one of these, right? So now if I were to click that face and I were to, let's say I can just right click and export DXF DWG. And then, let's just name this DXF example, and then hit save. So it's going to bring us into an output feature or a command, right? And you can see that it is just choosing one face. Well, because I've done it sheet metal, I can choose sheet metal, and it's going to choose the whole thing, but it's an extra step, right? So by default, I right click the part and it defaults to this face here that I right clicked. So if I were to hit this green check mark, you can see it's not the entire part, right? So I can hit cancel, and I could come up here and hit sheet metal and do it again, and you can see there's my entire part. But you can see that it has added lines on all of these tangency for my bends, right? So if you were to send this to a laser or send this to a plasma cutter, it would cut all of these lines by default, or someone would have to go in and be like, okay, only cut the perimeter, right? So that's not what we want either. So if I hit cancel one more time and I cancel this, what I'm going to do is I am going to, again, I'm going to edit my flat pattern, and I'm going to hit this merge face button right here. So now when I flatten this, you can see it comes automatically in as a solid face. So if I right click and export to DXF, and we'll do DXF example again. And now you can see that it automatically, so no matter if I choose this sheet metal feature up here, it automatically chooses the whole face. And then when I hit the green check mark, you can see that it doesn't have all of those extra lines that are just going to get cut, which is not what we want, right? And then if you hit save, it's going to save that DXF, and then you could send that DXF to whoever you needed to send it to. Okay, last thing I want to talk about is corner treatment. Last thing in flat patterns is corner treatment. So this is a instance where sometimes the corner, so the auto relief, the corners that SolidWorks creates in your sheet metal parts, when you flatten them, sometimes they won't look like you would think. Like this makes sense from this. If you were to flatten that out, it makes sense that it looks like a three sides of a rectangle, right? But sometimes, and I will edit this flat pattern and uncheck this corner treatment just to try to give you an example. Sometimes when I hit, and it's going to do it again. It did this last time I did this presentation as well. Let me try a different part here. I don't know what's causing it not to act like I know it's supposed to act, but it's doing it. Yep, it's not going to do it for me here either. Okay, so I'm going to hop back to my presentation real quick just to give you an example, because SolidWorks it can be a little finicky sometimes, and it's not doing what I want it to do for some reason. But so this last point here, these bottom two pictures here, you can see that in the flat pattern, just like I showed you earlier, this modern flange, when you flatten it, this bend allowance here, or this corner treatment, should be a rectangle. But you can see in this picture, I just skipped it. You can see in this picture here, it has made this corner just look like a sharp triangle, right? So if you ever get that, if you ever flatten your part and your bends or where your corners are look like that, the fix is right click your flat pattern, edit, and then make sure your corner treatment is turned on. And that will make it so when you flatten, your corners look like they should. I need to figure out why my example isn't working like I want it to, but I promise you it does happen sometimes. I'm not just crazy. Okay, so let's hop back into the presentation one more time, and let's try to breeze through the next little bit of this presentation, because we are definitely getting close to our time. Okay, so the next thing I want to talk about is geometry gone rogue. So this is anytime you have to, you have a imported geometry, a part that was sent to you, maybe it was sent by an outside, someone you outsourcing stuff to, and you need to convert that imported part to sheet metal. So the first thing I want to talk about is 3D Interconnect is a feature inside SolidWorks that, and I can show you how to turn it off there, that basically it allows you to use external CAD files in SolidWorks while keeping things connected and up to date. So if you're working with someone that you're outsourcing stuff to constantly, and they make changes to their part that they sent you and you want those changes to carry over, you want to turn this 3D interconnect on. But if your job, like day to day, what you're doing is you're going and you're taking an imported geometry part and you're converting it to sheet metal, you absolutely want to turn 3D interconnect off. It will make your life very difficult if you have it on trying to do this. And how you're going to do that, you're going to go to your little gear icon, your settings icon in SolidWorks. You're going to come down to the import tab, and you're just going to uncheck that interconnect or uncheck the enable 3D interconnect button. So as far as taming imported parts, there are two questions that you want to ask yourself before starting, right? The first one is, does the imported part have uniform wall thickness? And then the second one is, are there bend radiuses already there? You know, has the person that created the part already inserted radiuses to make this look like a sheet metal part? So the answer to the first question is, if you have uniform wall thickness, you ideally use insert bend. Insert bend is the best command for it, right? If you don't have uniform wall thickness, I would recommend convert to sheet metal. And then if your part has bends already or has radiuses on the corners already simulating bends, then I would utilize a feature that I'll show you called delete face. It is actually in the like the surfacing realm of SolidWorks, but I think it can be very useful when it comes to imported parts. And then once you do that, if you have uniform wall thickness, after you take care of those bends or of those radiuses in the corners, then I would just use insert bends again, right? So I'm going to hop into SolidWorks and give you an example here. So let's go to, okay. So you can see this is a imported part. It looks like a sheet metal part, right? But you can see I don't have any sheet metal features over here. The only feature I have in the feature tree is the imported feature. So I can come in here and I'm like, okay, it looks like uniform wall thickness, but let's check a few times, right? I click two faces and I can see down here on my tooltip at the bottom, I got 1/8 inch. And maybe I can click these two here, again, 1/8 inch. Over here, I have 1/8 inch. Okay, so I can very, I can say with pretty certainty that I think this is uniform wall thickness. So like I said earlier, we're going to use insert bend. So I'm going to come up here and I'm going to say insert bend. And converting a part like this that is uniform wall thickness to sheet metal with insert bend is super simple. I'm going to click a fixed face and I'm going to click the green check mark. Done, right? So now I have a flattenable sheet metal part. It has set my bend radius automatically, and I will undo it one more time. Just undo it just to show you one more time. I do have the option to set the bend radius up here. And then it just automatically creates the imported part. So if you had something kind of like our original imported part or our original insert bend, right? If you had something like this that was imported that had some edges that need to be ripped, you would still have to do that, obviously, right? But insert bend is a super powerful command for sheet metal or for imported parts that have uniform wall thickness. Okay, well, what if the part doesn't have uniform wall thickness, right? So like this one, we can obviously tell that this leg over here is bigger. So you can see it's 1/4 inch thick, whereas this here is 1/8 inch thick. So what if I was like, okay, can I not use insert bend for it? Well, I can, but when I do it, you can see that it does not use, or it does not convert that additional material that was a different thickness to a sheet metal part. So it still did it, it just didn't do it like we wanted to, right? And the reason that it does that is if I hit insert bend, like I said, I can choose a bend radius, but there's nowhere in here that allows me to choose what I want the material thickness to be, right? So because I chose this face first, it's going to look at it. It honors the thickness of the material that is already there. So yeah, it honors that material thickness. So because this leg over here is thicker, it does not recognize that, and it's not going to convert that to sheet metal, you know? So instead, what we're going to do is we're going to use our convert to sheet metal command. And just like we did on the other convert to sheet metal part, we're going to choose a fixed face, and then we're going to choose our bends, and choose our edges that we want to be bends, right? And I can zoom in here, and you can even see that I actually have a choice for sheet metal thickness here. So I'm going to set it to 1/8 inch because that's what I kind of wanted it to be. But you can see that even though this leg over here is thicker, you can see where it's not honoring that thickness, right? It's honoring the thickness that I have set. So when I hit the green check mark, and I had that keep body turned on from earlier, turn that back off. Okay. I now have a sheet metal part that is uniform thickness that can be flattened, right? So the last question that I told you that you needed to ask yourself was, what if it already has radiuses on the corners? So you can see this looks a lot like that sheet metal part I just had. It's got radiuses inside and outside. This one's very small, but it's got a radius there as well. But you can see that it's not a sheet metal part. It is imported as well. So if I were to try to just insert bend on this, click the fixed face, you can see that it's going to give me an error. Insert bend doesn't look, it doesn't see these radiused edges as an edge that it can add a bend to, right? So it's like, okay, well, could we not use convert to sheet metal? Yes, we technically could. And I say that. Sometimes it works, sometimes it doesn't. But let's see if I can simulate it to work. Okay. So yeah, so if I click that, you can see it's going to add my bends. But the reason that we don't use convert to sheet metal in this instance, and I'm going to show you, I'm going to tell you why, is once I do this, so I have a bend radius set up here. You can see it's defaulting to 0.1345. But I don't know if you noticed, and actually it's not going to let me do it. Sometimes it will let me do this and sometimes it won't. But even if it does let you do it, the reason that you don't want to do that is because it does not, the bend radius that you use in convert to sheet metal is, it's set via like default, right? And even if you were to change it, if I were to override the default, it's going to honor the bend radius that is here. So, because this is an imported part, it's not going to show me what this bend radius is. Even if I hit my little measure button, it's not going to show it. But I can tell you that I created the part, and I know that this bend radius is only 1/16 of an inch. And for anyone who's ever worked in sheet metal, there is a just like universal sheet metal rule when it comes to bend radius, and that is your inside radius should never be less than your material thickness. So I have a material thickness of 1/8 of an inch. So that means that my bend radius needs to be at least 1/8 of an inch or larger. Otherwise, it will not be manufacturable. So even if that convert to sheet metal would have worked, which it didn't for me, it would not have made, it would have honored this 1/16 of an inch bend radius. And from that universal rule that I just told you, we know that that isn't right. So what I'm going to do is I'm going to show you easiest place to find it is in the direct editing tab. Again, just like the sheet metal, if you don't have it, if you right click, come down to tabs, and you can turn direct editing on, or you can search up here. But what we're looking for is the delete face command. So even though this is not a true sheet metal feature, when it comes to imported geometry and making sheet metal parts from that, it is a super useful command. So I'm going to show you how it works. You click the delete face button, and we're going to focus on this delete and patch option here. And what I'm going to do is I'm just going to go through and I'm going to click, and I am going to have to do this in two different features or commands. I'm going to have to do outside first. So I'm going to click all my 4 outside radiuses. And with this delete and patch option chosen, when I hit the green check mark, you're going to see it deleted the radius and it patched it to make it a 90-degree sharp corner. So I'm going to do it one more time just to get the inside, like this. And then when I hit the green check mark again, you can see I now have a sharp corner. So now I can come to sheet metal and I can choose, I already have this chosen. There we go. Now I can choose insert bend. I choose the wrong button, insert bend, choose my fixed face. I can set my bend radius. And when I hit the green check mark, I now have a sheet metal part that has the accurate bend radius that, again, can be flattened. Give us a bonus trick to use while working on sheet metal. I actually have, so this whole next section is a section that I am going to call the bonus section because it is something that I think is cool that utilizes sheet metal features, but doesn't actually, but not for actual sheet metal parts. So I'm gonna cop out a little bit there and tell you that this is going to be your bonus feature because I think we're already technically at that time, but I think everybody will enjoy this, and I don't mind staying here a little longer and sharing it. So the last section of my presentation is what I call think outside the fold. Creative solutions using sheet metal features. So the cool thing about sheet metal features is you can utilize them for things that aren't sheet metal. For instance, anything that comes in a sheet good, so plywood, your like HDPE and PVC and ABS plastics, they all come in a sheet, right? Like when you get them from a supplier, you can get them in the sheet form. And the cool thing about that is because they come in sheet form, you can use sheet metal features to create and make those parts. And it, in this case, in this particular example, like a piece of plywood, it makes exporting to DXF and DWG for like a CNC or a router table super easy. But then also if you happen to work for a company that does any kind of like plastic welding and plastic bending, you can also use sheet metal features and, for like HDPE purposes as well. Of course, there would be some, you would have to do some research and working with your manufacturing team to figure out like what kind of K factor and stuff like that you would need for materials that aren't sheet metal, but it is absolutely doable. But I do want to hop back into SolidWorks real quick and show you an example of what I mean. So I have 2 plywood parts here. So you can see that I have a notch or like a half lap feature in this plywood part. And this first one is, I created it and then I converted to sheet metal, right? And then the second one, you can see the part looks exactly the same, but it was not converted to sheet metal. And I'm going to show you just kind of the same kind of thing that we did earlier with flat patterns where we were exporting to DXF or DWG. by creating this using sheet metal features, if I were to right click and export, and we'll say example again, I now have, because I created it with sheet metal, I now have the option to export using sheet metal. So when I click the green check mark, you can see that I have the entire part. So of course, in order for this to be cut properly on a router table or CNC, the CNC operator would have to know that, like, hey, this line here is not a full cut. So you would have to denote on your print for your fab team that this is only, cut 40% of the way through or whatever it is. But you creating this part using sheet metal features allows us to get the entirety of this part in a DXF, right? Whereas if I were to go back to this plywood piece that is not sheet metal and do the same thing, example again, you can see I don't have the option for sheet metal. Now I could, click in this entities to export and click this other face and green check mark, and now I got it again, right? But I don't know if you can tell here, and I will scoot this over so we can kind of see. You can see that this part, it is flipped. It's mirrored from what this actually is. So like if I were to flip it over like this is kind of what that DXF is exporting. But you can see that half lap is on the wrong side, right? So ideally, you create this as a sheet metal part. That way, when you export, you can choose sheet metal, and then you can see that this one is oriented the right direction with that square cut out on the right side, and that's the side of the part that the half lap is on. Okay, so that is using sheet metal parts for other sheet goods, right? But there's actually another thing that we can use sheet metal features, sorry. There's actually another thing that we can use sheet metal features for that is very unique. And that is pipe and rod, to be exact. So sheet metal features can be used to create bent pipes and round stock. And the cool thing about this is it gives you the ability to flatten the part. That way, on a print, you can get a pretty accurate pre-bent length. So if I were making this non-sheet metal, getting it, the way that you would make something like this part is you would cut the part longer than you know you need. You would bend it, and then you would chop off what you don't need to get it the size that you need, right? But if you were to use sheet metal parts or sheet metal features to make this part, and I have examples here as well. If I use sheet metal features, and I'll show you kind of how I do it. So what I did here is I actually created a base flange. So I didn't convert to sheet metal on this one, right? I started sheet metal, and I just made sure that my thickness and radiuses and stuff like that was set to what I knew my diameter of my pipe was, right? So I just made it a square first, and then I filleted the outsides to make it look like pipe. Well, now it's still solid, so I just sweep cut to get the inside cut out, right? So the cool thing about this is it now gives me the ability to flatten the part. And I'm going to come over to a little more complex grab handle here because I have a print for it. But you can see I now have the ability to flatten this formed rod or pipe if you're doing pipe, and it allows me to give a very accurate length. So now my fabrication team knows when they go to bend this part, they need to cut it when they go to cut this part to bend, they need to cut it 26.64 inches long in order to get the part that is exactly this size and shape. And in this case, so just like with any other sheet metal stuff or any other bent fabricated parts, this will be something that you will definitely have to work with your fabrication team with, right? We have, so at ALTEC, we had a team of people that this is what they did. You know, they went and they cut a bunch of test pieces because in SolidWorks, you still no matter if you're doing it for actual sheet metal or you're doing it for this unique application of rod or pipe, SolidWorks still has a K factor, right? It still has it's still looking at it like it's an actual sheet metal part. So the default may not be accurate. So you definitely need to work with your fabrication team to really dial in what your settings need to be as far as creating those sheet metal parts. But I thought it was pretty cool being able to utilize sheet metal part or sheet metal features to create parts that aren't actually sheet metal. So with that, I think that is the end of my presentation. Do I have any more questions? Johannes, did you record this, by the way? Because someone's asking. Okay. Yep. You already answered it. Never mind. Okay. Any other questions for me? It looks like Johannes created a Q&A. So you can, where did my chat go? There it is. Put those questions in that Q&A and I can answer them. I really appreciate y'all joining. The praise is very thoughtful. What should I do for the CSWP sheet metal exam? So there should be a sheet metal practice exam. I would definitely utilize that. I would definitely give a look to, I mentioned Too Tall Toby earlier in the presentation. Give a look to his YouTube channel. He's got a bunch of sheet metal presentations. A lot of it will cover a lot of what I covered here, but he covers some other stuff as well. He definitely goes into a little more detail and into like the K factor and stuff like that than I did. But that would be a good resource. But to be honest, I think the best resource, and I hate to give this as a resource because it's not a free resource. I hate giving things that aren't free or telling you to utilize things that aren't free. But LinkedIn has a their like LinkedIn Learning section of their website, which is what you get as a premium LinkedIn member. They have some really good SolidWorks certification prep videos. As far as I know, that's the only way that you can access those prep videos is through LinkedIn Learning. So it's unfortunate that it is behind the paywall, but I will say that for your CSWA, your CSWP, your sheet metal, your drawing tools, and your weldments exam, the certification prep videos on LinkedIn Learning are phenomenal. I think the guy's name is Gabriel Corbett, is the guy that does the videos and those presentations, and he does a fantastic job of going feature by feature and showing you exactly what every feature does and shows you what features you need to know to take the exam. Other than that, if the behind the paywall is a deal breaker for you, I think Too Tall Toby and other YouTube SolidWorks people are probably your best bet. And then, of course, like I said, make sure to check out the practice exam, because it's going to give you a good idea of some of the things that you need to know, as well as the My SolidWorks should have some stuff on it as well. If I were to create a crate from plywood to hold beer, the intersecting plywood, how would you go about designing that? So you're talking about like half lap. So kind of like this part here, right? Yeah, so same kind of, so I'm going to use this as an example, right? That's not a great example because it's so many different angles. But what you could do is you could create a multi-body part like I did here. You know, again, that's one part, that's one part, that's one part, right? And then I can edit these parts individually in this, right? So if I were to want to cut this highlighted face back, I could sketch on that face. I could draw a rectangle. Let's do it this way. Let's go convert entities and convert entities, and then maybe that one as well. Convert that one, and then I can offset this one. Say I want a 1/16 of an inch tolerance, and then I can come in and do some trimming here. Okay, and then trim there, and then I could cut this, length to thickness, green check mark, and now you can see I've cut that part, and it cut in the it cut this part as well, which was not ideal. So what you would probably need to do is let's undo that. I think what you would have to do here is you would have to save these parts out individually. So you should be able to click that and file, save as, say new part. This may not be the way to do it. Let's try it real quick. Now it's saved the whole thing. Okay. So the way that you would actually do this, let's go back. Oh crap. I just closed it. So the way that you really want to do convert to sheet metal parts, or you do multi-body sheet metal parts, is you would let's open that part back up. Where did it go? Convert to sheet metal. Open. So the keep body feature that I showed, so what I would do is I would use this as a master part, and I would say, okay, file, save as, and I would say, side pieces, and then under side pieces, I would convert sheet metal, convert here, bend. So there's one sheet metal part, and then I would come and I would open this again, and I would do another save as, and I would say front piece like this, and then I would convert to sheet metal one more time. So base there, bend there, right? Okay. So that would be how you would get your multiple pieces. And then what you could do is you could do an assembly with the original part. So I can open this part up here and add it to an assembly. Start assembly. Check mark. And then I can bring those parts in and say front piece. And I know that it was mated like this and like this. Right. And then, so then with these in the assembly, that would be where I would do my, so let's go ahead and bring the other piece in. Hold up. Side piece like this. There. I probably just made origins, I bet. Let's see. Origin to origin. And then origin to origin. Okay. So then from here, I can hide that original thing. And this would be where I would do what I just did earlier, right? You could edit this component by itself and do your sketch and then cut it back where you need it. Would just cut that part. Sorry, that was a long explanation because I, even though I know how to do multi-body parts, I do not do a lot of multi-body parts. So, but that would be how I would recommend doing it. Is you could absolutely make the part, make all the pieces here to kind of see how it's going to be. But to make your changes to the pieces, you're going to want to save them individually and make them that way and then bring them into an assembly. Last question. What's your preferred way of nesting on sheet? So you're talking about like nesting it for a laser or for a plasma to be cut? Okay. Unfortunately, I can't give you a lot of information on that. We have a team of people at my work that's what they do. We have we call them programmers. So they program all of the like laser and plasmas, and then they also program like press brakes and stuff like that. I know that we use a software that has some like default parameters that you can just, basically hit a button and it automatically nests it the most preferred way. Unfortunately, I don't know if I can just tell you what that is. I don't want to make anybody mad at my company if that's something that they try to keep on the down low. So unfortunately, I don't have a good answer for that. I don't do a lot of actually nesting as far as like for lasers. I will say at the company that I had or that I was at before where I'm at now, I did run the laser a little bit, and I know that the laser that we had software built in that would nest it automatically. I know that you definitely want to keep in mind how parts are bent. So you don't want, so just like wood, sheet metal has a grain in it like wood does, and you don't want to bend with the grain. You want to bend against the grain. So you want to think about that when you nest stuff. You want to make sure that, because it in most applications it's probably not a huge deal, but I know when you start getting into like thicker materials like 1/4 inch and 3/8 inch steel, and stuff that is very needs to be very structurally sound. You can get some breaking and tearing at the bends if you don't orient your parts correctly, if you don't nest them properly. But other than that, sorry, that's all all the information I can give on nesting. Okay. Any other questions? Doesn't look like it. Well, cool. Thank you, everyone, for joining. Thank you for staying late. I think the majority of people stayed later than what this was technically scheduled for. Yeah, that's all I have. I appreciate y'all, and feel free to connect with me on LinkedIn if you want. If you ever have any sheet metal questions, I try to be pretty responsive. Shoot me a message on LinkedIn or something, and maybe I can help.
All right. Thank you very much, James. So that brings us to the end of our today's session. And I want to sincerely thank James Letson for sharing his time, experience with us. His presentation on Solidworks sheet metal was packed with valuable insights and practical techniques that we all can apply in our works. And also a big thank you to all of you, everyone who has joined us today. Your engagement, participation makes this meeting very meaningful. And if there is anyone who would love to revisit today's session, the recordings will be available on our Telegram group and on our YouTube channel. Thank you, James.
Thank you so much. Have a good one.